This is on similarity. Something is similar when they are proportional. For example, let me see if I can see. I'll do this easy one. Okay. Is on this one. What can I multiply 3.5 times to get 7? By 2. Okay, and so that equals 7. In fact, because all of these sides are the same, they're all 3.5. So who knows what all of these would be? Because it's a square. They would all be 7. So it is proportional. I don't know what that is. All right, so we're going to go to down here. It says determine whether the ratios are equivalent. There's 2 different ways that you can do it. You can either cross multiply. In fact, this is an easy one to cross multiply. So I'm going to cross multiply this way. 6 times 8 is, what is 6 times 8? Is 48. And you have to do it in an upwards direction. And then 56 times 1 is 56. If those are not the same, the ratios are not equivalent and they're not proportional. So this is it proportional? This is a no. No? Okay. Then, on this one, again, there's another way that I could do it, is I could go across, already 2 that are no. So this one I'm going to go across times 11 is 22, but times 11 is what? 1 times 11 is? 11. Isn't 1 times 11 11? Yeah. So are these proportional?
Yeah.
2 times 11 is 22. 1 times 11 is only 11, but they had a what there?
12.
So are they proportional?
No.
No, they would have. This would have to be 11 over 22. So this is a no. Okay. Then on this one, this looks like it's too much work for me, but I can already tell it's not.
Wait, am I sure?
Yeah.
So wait, on 3, like how you did it on 2?
I can do it the same way. So in fact, I could cross multiply. 2 times 12 is 24. 1 times 22 is 22. Are those 2 numbers the same? Yeah, so no. So they're not equal. Okay. Then on this one, I don't want to cross multiply because it's too hard. So I'm going to instead divide by 3 to get 5. But on this one, can I divide by 3?
No.
No, I can't divide by 3. I can't do it. So this is also a no. 3 no's. In fact, there's a no, no, no. I'm hoping these are okay. All right. In fact, who knows 0.2 times what will give me a 0.6?
3.
Times 3. And in fact, if I multiply this by 3, 3 times 16 is 48. It is, so this one is correct. So this is going to be, and in fact, also, just to let you know, I could have moved the decimal over 1. I could have gone 16 over 2 and moved this one over 1 and put it 48 over 6. And then I could have still done times 3 is 48, times 3 is 6. So this is a yes, or they are equivalent. I don't want to do this one. Well, yes, I'll do it. Who knows 0.3 times what will give me a 21?
7.
A 7. So I just need to check if 7 quarters is $1.75. Yes. This is a yes. They are equivalent. Okay. All right. Let me see.
Yes.
Alrighty. So find the missing angle. I don't think I want to do that. Name the corresponding parts. All right. So here are 2 polygons. How many sides? 1, 2, 3, 4. Quadrilaterals. And they just want to know what is the corresponding side to BC. If this is BC, look over here. Which one do you think is the same angle, same shape?
QR.
Is the QR. So this is going to be similar. In fact, they tell you they're similar, which means everything is proportional. And then on angle D, what angle do you think corresponds over here to the angle D?
S.
The angle S. So, and by the way, if this is 94 degrees, over here, this is going to be 94 degrees. The angles are all the same. The sides are different, but proportional. So this is going to be congruent to the S or corresponding to the S. And then what corresponds to the angle C?
R.
It's the angle R. And what is the length of PQ? Where is PQ? Oh, okay, it's right here. So now we're going to set up a proportion to find this side. So I'm going to go over here and I'm going to pick, there's 1, 2, 3, 4 numbers. I need this corresponding side for sure, which is the BA. So I need the BA, and I'm going to put the BA right here. So what's the measure of the BA?
6.
It's going to be 6. And then right under it, I'm going to put the QP, and that's what we're looking for. And we don't know what that QP is. This is number 12. So again, I'm looking for the QP. So I'm taking the corresponding side, which is the BA. That looks like a PA. Okay. 6, and I'm looking for its corresponding side, the QP. Then over here, I'm not going to take, I need 2 other numbers over here. So this top one was for the bigger one, the bottom was for the smaller. The problem is that I can't take this one and this one because there's nothing here. So I've got to take, who knows where there's a number on the smaller one?
On the right.
On the right, which is the R to S. So I know this one, R to S, is 8. That's R to S. Which is the corresponding side to the RS over here?
C to D.
The C to D. So this corresponds to this. And then, let's see if you can do it in your head. So if Q times, this is Q times 12. I don't know what that is. It's Q12. Well, if these two, 6 times 8 is 48, who knows what number this has to be? Blank times what? Blank times 12 would give you 48. Who knows what that blank would be? It would be 4. Or I could reduce this. So I could reduce it, divide it by 4, which makes it a 3. Divide it by 4 makes it a 2. And then I could go back this way. 3 times 2 is 6. 2 times 2 is 4. So that Q to P is equals 4. All right. Then I want to look for the length of Q to R right here. Okay. What corresponds on this one to Q to R? Is the what? Is this one, yeah. So I can put those 2 numbers. I'm going to put 8 is equal to QR. Okay. Or they're similar, they're proportional. So this 8, and this is the one that I'm looking for. And then I need 2 other numbers. The first one has to come from here. Who knows which one I can pick? And if you pick one here, you have to have the number over here. So who?
Oh.
Well, I'm looking for this one right here. I'm looking for this right here, and so I'm picking that one. 8 is equal to the QR. But then I need another number from here. Who has an idea which one I can pick? Well, I've already used the 8. So I need a different one. The only thing is, on that 6, do I have a corresponding number here? I need 2 numbers. One from here and one from here. Who sees a side where you've got a number on both the same corresponding side? Somebody just said it. The 12. Here's a 12. And isn't there a number here?
Yeah.
So these are the 2 that I would choose. A 12 and an 8. And then I'm going to do the same thing. I'm going to go ahead and reduce this and dividing it by what? By 4, by 4. So I end up with 8 divided by 4 is 2. 12 divided by 4 is 3. All right. And then, okay, let me just look real quick and see what you've done.
Dang, support.
Yeah. You know, you'll get this corresponding daily grade. Dominic, you'll get the corresponding daily grade. All right, so on this one then, again, I can't do anything except I can't go across this way, so how would you solve that? This one. Cross multiply. So on this one, it's going to be, and just find some room here, it's going to be 3Q is equal to 2 times 8 is 16. And then how am I going to get rid of that 3? Divide by 3, divide by 3, and we'll leave it as a fraction. So this side that I'm looking for, 16 divided by 3, how many times does 3 go into that? 5 times. And 5 times 3, and I guess I'm going to get this because you were missing some of these. 5 times 3, and you're right, 1 left over. Very good. Is 15 minus that. I've got 1 left over. So that is going to be, this side here is 5 1/3. Okay, and I don't think I want to do this perimeter. Oh, we can do the, no, I don't want to do that one. On the perimeter, I would have to find, I've got this side, they're looking for the perimeter of this one, but I don't want to take all day. We know this side. Okay, you're here. Good, good, good. Thank you. Oh, what is that? Is it somebody's birthday?
Yeah.
Whose birthday is it?
It's mine tomorrow.
Okay, I think I'm going to go for this one. Thank you.
Here,
Woohoo!
here's a tissue.
Oh, thank you, thank you. Thank you, girls. All right, so I have this side, the QP side, we have 4. I would, okay, I've got all 3 of these. How do you find a perimeter? Yes, ma'am.
In the bottom, I'm supposed to cross out the answers?
You can.
Because it says 5 and 1, 2, but not 5 and 3. And
Well, you know.
Can be.
Okay, hold on. Let me make sure I did it right. 8 divided by 4 is 2. 12 divided by 4 is 3. This is correct. I think that's incorrect. And if I made a mistake, I'll go back. But yeah, for paying attention, yes, I'll give you some candy. All right. I don't have time to find the perimeter of this. I would still have to find this side. But I'm going to instead find the perimeter of this one. Do we have all the sides on this one?
Yes.
So how do we find a perimeter? You parade around. The P stands for parade around, plussing all the sides. So I'm going to plus 4. And 6 is 10, 8 more is 18, and 18 and 12 is, I think it's 30. So we're doing the perimeter of the first one. It is 30 centimeters. And then, some of the answers aren't there, so don't worry about it. Is on, now they want the measure of the angle Q. So here, where's the angle Q? Here's our angle Q. So look on the first one, what angle on the other one corresponds to the Q? The B. So those angles are exactly the same. The sides are different proportionally, but the angles are the same. So that Q is going to be 126 degrees. What is the measure of the angle R? We're looking for, oh, this one right here. Oh, okay, this is interesting. What's that? Number 14, we did the perimeter of the first one, which is 30. But this one, this is really taking more time than I wanted, but you need to know this. Okay. Does anybody know how many degrees are in a triangle? When I add up all of your degrees, girls and boys, it's either going to be 180, 360, if I add up all the degrees. It's 180. Every single triangle adds up to be 180. This could be 100, this could be 20. This is, my picture isn't accurate. So 120 plus 60 more would be 180. They always equal 180, no matter what. If you have a quadrilateral, however, I'm going to draw a picture like this. And I draw a diagonal, and I've got two triangles. Again, how many degrees in one triangle? 180. How many degrees in another triangle? 180. So to find the degrees in a quadrilateral, you add those up. There's 180 and 180. It is 360. So, going down to their question here, it says, what is the measure of R? I can't find the measure of R until I find the measure of the C. And again, so this takes some work. Is this a triangle? No. So this has more than 180. In fact, we just did a quadrilateral. 1, 2, 3, 4. In fact, on this, there are 2 triangles. If I draw from one vertex to a non-adjacent other vertex, there's 2 triangles. So how many degrees would there be altogether? 360. Very good. So 180 is 360. Well, if I know this one, and this one, who knows how I can find the missing angle? Who said that? Very good. You're going to add up the 126, the 94, and the 100. So we'll just do it right here. 126, 100, and 94. So let's see what that adds up to be. So this is going to be 10, 9 and 1 is 10, 11, 12. So 320. Well, if the whole thing totals to 360, who knows how I can find that missing angle now? Is subtract. So take the 360 minus the 320, and so that angle is 40. So if this angle is 40, what is the R angle going to be? It's also going to be 40. That's a lot of information. I didn't mean to give you so much information. Overload. It truly is overload. Let me look at our... What?
I don't understand it, but...
We'll do it again, so don't worry. What time is it? What time is it? Let me see what time it is. We get out of here at 37. Okay, so let's see what we're going to do. All right, so flip it over to... Okay, let's flip it over to here. Okay. All right, so never mind. We're going to flip it over to the very back. Okay, flip it over to the very back. And what we're going to do is find the missing number. All of these rectangles, polygons are all proportional, such that if I set up a proportion and I cross multiply, I should be able to find the missing number. Some of them, however, are super simple. So let's look right over here. So they're telling me these are proportional. So who knows what I could multiply 9 times to get 90? 10 times 10. So that's 90. So if that's true, what could I multiply 13 times to get this side?
10
times 10. So that gives me 130. Well, given that information, who thinks they know what this side is? Yeah, and I could actually go back the other way. I could divide this by 10 to get this missing one. And again, most of this was visual, but if it's turned the same way, you can just do it like this. Like this one is real simple. So I'm looking for the x, but I'm going to do it the correct way. I'm going to take any 2 numbers. I'm going to take the x and the 12, and then I'm going to take the same 2 numbers over here, or the same 2 corresponding sides. I'm going to take the top and the bottom, and I'm going to put x over 12 is equal to 3 over 3. Does anybody have an idea what that x is going to be?
12.
Do you want to cross multiply? Okay, so let's cross multiply. 3x is equal to 36. Who knows 3 times what will give you 36? Times 12. So I'm going to divide by 3, divide by 3. It is 12. In fact, if these two are exactly the same, these two would have been exactly the same. So that missing side right here is 12. They're isosceles triangle. 2 sides of the triangle are the same. Okay. Then when you get down to where they're turned around, then you have to be especially careful. Which of these is the smallest side on the 19? Yeah, the 4. So it I'm going to put a little 1 notch for it being the smallest. Which is the smallest side on the triangle to the left? The x. Okay. So in just a second, I'm going to set this up. I'm going to set the 1 notches together. So I'm going to do the x of the left side to the 4 on the right triangle. And then I can pick any other number on this one. Pick one of the 44 or the 52.
44.
Okay, so 44 is the next smallest side. So it's going to get 2 notches. Who knows the next smallest side on this one? It's the 11. So now I'm going to set up the 2 notch. The 44 to this one. And we did all that other stuff, but this is the most important today. And then we set it up. It corresponds to this 11. Then, does anybody see the answer? What do you think it is? Careful. In the direction of the x. It's going to be 16. Very good. So 11 times what will give me 44? A 4. So 4 times 4 is what? Is 16. So that x is equal to 16. Okay. And then this one here is a mental. Okay. 7 equals 7. 5 is equal to 5. It's a perfect rectangle. Who thinks they know what this one is? 56, right across. There's no work to do. Okay. Then, okay, let's go over to this one. Okay.
That one was so hard.
Okay. It's not that hard, right? So, which one is, okay, which one is the longest side on the 21?
91. Oh, no, X. 42.
I'm looking at this one.
11.
So I'm going to put, there's 4 sides. I'm going to put 1, 2, 3, 4 notches. What do you think is the longest side on this one? The X. That is the longest. So these 2 sides correspond. 1, 2, 3, 4. So I'm going to go ahead and set that up. 1, 2, 3, 4. That's my 4 notch side. So I'm going to put 11 to X. 11 to X. And then I can use any other number as long as I choose the corresponding side on this one. So I think what I'm going to do is I'm going to go, which one do you want to pick?
94.
I'm going to pick, actually the 4 looks really easy because 4 is the smallest side. What's the smallest side on this one? The 52. So I'm going to set up the smallest side to this one with the smallest side on that one. And then I'm going to go ahead, I don't want to cross multiply. I'm going to see first of all if 52 is divisible by 4. So 52 divided by 4, I think it's going to go. So it goes in once. 1 times 4 is 4. And 4 goes into 12 3 times. So I could go 4 times what to get 52?
13.
Times 13. And then to get my final answer, I go 11 times what? 11 times 13. And that's going to be easy to do. So 13 times 11. 1 times 13 is 13. And then 1 times 13 is 13 again. Just scoot it over once. So that side is going to be 3, 4, 1. So our x side is, the x is 143. Again, this was our longest side, and this you can see is the longest side by number wise. then this is an easy mental math one. 14. Because if these two sides are the same and the length is the same, then this opposite is going to be the same. X is equal to 14. But let's go, oh, this is an, what's that? What's 47? What's 27? Here?
No. I'm number 23.
Okay, well, let's look and see. Oh, yeah, this is a mental math also. Opposite sides are the same, so opposite sides are the same. Okay. But this one, these are all different. These are the kind that you need to know today. So here is my X. So I've got to figure out what side corresponds to that X over here. Okay, who can tell me, is this side here the smallest side on this one?
Yes.
It is? The X? No. This is the smallest. The 4 is the next smallest. In fact, I'm not quite sure, but anyway, let's go ahead and see how this one works. I'm debating, I'm thinking. All right, here is where, let me turn it this way. This side is where it comes up. There's a point here where this is going a little bit higher and then going down. So I'm going to look over here, and it looks like, who knows which one? What one? Careful. Isn't this side here where it goes higher? It's going to be 91. This is totally flipped. So this X, and in fact, it looks like it's the longest side. So this is the longest side, that's 4, and this is the longest side. So that X corresponds to the 91. And then I need 2 other numbers. Which one do you want to pick on this one?
21.
21, which is the smallest. So this one is the smallest. It corresponds to which one on this side? The 3. Because it's the smallest. So sometimes you have to put notches. And then we can go in the direction of the variable. Am I going to multiply or divide? Divide by what?
7.
Divide by 7. Divide by 7. And 7 does go into 91, by the way. So let's go ahead and find out how many times. When 7 goes into that, how many times? What? 3 times. So that side, my X side is 13. And let's see if that looks reasonable. This is our longest side, and it corresponds to this longest side. And that's it. Our X is 13. Alrighty. So I'm going to go over to hold on one second. What time is it? All right, I'm going to try to make this easy. Now, when the pictures are, and you're not going to have to do all these, when they're turned around the same way, it is super easy. Super easy. All you need to do is draw a line in between these 2 numbers and do the same thing here. And there is your proportion. 12 over 20 is equal to what over what? 3 over x. Then in the direction of the x, am I going to be dividing or multiplying? Dividing by 4, dividing by 4. What our x is equal to 5. Again, super easy. Same thing here. If they're turned the same way, just draw a line in between the 2 numbers, and there are your 2 ratios. X over what? X over 1 is equal to what over what? 9 over 3. And then again, in the direction of the x, am I multiplying or dividing? And when you're not quite sure, cross multiply. 3 times x is 3x. 1 times 9 is 9. 3 times what would give you 9? 3. our x is equal to 3, or divide by 3, and x is equal to 3. I really want to do, yes ma'am, go ahead. Okay, we don't have a lot of time, so let's, all of these, we don't have to do these because they're all the same. This one's kind of hard. Well, who can tell me what I'm going to set up on this one? 10 over 9, is that, all right, so these two sides, are they the same? No. It looks like this side and this side are the same, and this is my base. I can't tell. This,
You just have to turn it. Like,
you have to turn it so,
10 over 9.
so it looks like this is my base, this is the smallest, and my base here is, what do you think? I'm thinking it's the 99. That's the smallest side here. And the other one is the other side, so I'm just going to say this is our second one, and this is our second one. So I'm going to go ahead and set up the, I'll put the 2 notch over the 1 notch. So the 2 notch here is what?
10.
Is 10 over the 1 notch is 9. And then go to the other side. What is our 2 notch over here? The two notch is what? Is the x over the 1 notch, which is what? The 99. So these are a little tricky. And then can I go in the direction of the unknown? 9 times what will give you 99? Times 11. So 10 times 11 is 110. And we'll see if we can set, oh, these have to be the same. I think this is an easy one. If this is 10 and this is 10, guess what this one's going to be? It's going to be 100. Okay. All right, and that's there. So don't worry about doing any of those. This is the page that we're going to do. Okay. And I'm going to help you set up the proportion, and then you're going to solve it. So on this one, okay, we're looking for what side? We're looking for the x. So for sure, I have to bring in x. What's the corresponding side to BC over here? What? Okay, I'm looking for the, here's the x. What's the corresponding side to this BC? This EF, yeah, it is the 6. So I'm going to put the 6 right here. Then I've got 2 numbers left. Pick whichever one you want. Let's pick the 15. If we pick the 15 for this one on the left, what are we going to pick for this one?
10.
The 10. Very good. You pick the corresponding side. And then we probably, oh, this is easy to cross multiply. So this is going to be 10x is equal to 90. Who thinks they know what the x is going to be?
9.
It's going to be 9. Because 6 times 15 is 90. Okay. And then I just divided by 10, divided by 10. And so it's going to be 9. However, I could have also reduced, cut it in half, cut that in half, and then gone across. 5 times what will give you 15?
3.
Times 3 times 3. So 3 times 3 is 9. You get 9 no matter what. Okay. But I'm going to help you, and in fact, I'm going to help you set up this one, because this is cut and dry. Because they're turned the same way, I just need to draw a line here and here. So who knows how I'm going to set up my first fraction? Guys, get this down. How am I going to set up my first fraction?
Y.
Start with the left one. What's the fraction for this? 5.2 over 6.5. 5.2 for the left trapezoid over 6.5. Who knows how I'd set up the fraction on the other side? Y over 2.5. and I don't want to cross multiply, who knows what I could do with those decimals?
Divide by 5.
How can I get rid of the decimal? It's just move it. Move it over once, move it over once. And I think you might not know this, but I look for this when I see numbers that are going to be too hard. Trust me, I never give you on a test numbers like that. If I do, it's because they can be reduced. I know 5 times 13 is 65, so I'm going to see if 13 goes into 52. So 13 times 4, that's 12, and that is 52. There we go. So I'm going to go, oh, how would I do this though? But I'm going from now 52 over 65. Okay, I can't do it the way that I thought. Okay. I might have to cross multiply. No, I can reduce this. I can reduce this because both of those are divisible by 13. How many 13s are in 52?
4.
4. So I'm going to change this and I'm going to make it a 4 over. How many 13s are in 65? Should be 5. Okay, 65. So it is 4 over 5 is equal to y over 2.5. And then who knows what I'd have to multiply?
5.
Well, close. In fact, I'm going to cross multiply. 5y is equal to, what's 4 times a quarter? 4 times a quarter? 4 quarters? It's $1. It's 100. So it's 100, except I have to move the decimal over how many places?
5.
1 place. So it's really 5y is equal to 10. Who knows what that y is going to be equal to? It's going to be equal to 2 divided by 5 divided by 5. Y is equal to 2. And let's see if that's reasonable. So 2 is a little bit smaller than 2.5. 5.2 is a little bit smaller than 6.5. So that is a reasonable answer. So my y is equal to 2. Trust me, you're not going to have hardly any homework at all. Okay. Then, okay. I'm going to tell you right now, I will tell you right now, this problem will be on a test. So, this one right here. So, I'm looking for the x. Okay, here is the x. Who knows what side on this one corresponds to the x side? The 12, because if I turn this around, okay, here's the right angle, and the x is going straight up from the right angle. So, which side here goes straight up from the right angle? The 12. So I know that the x goes with the 12. Okay, so I've already accounted. In fact, that looks, the hypotenuse is always the longest, so this is actually the second longest. What other side? Well, there's only one side that I can use on this, which is the what? Which is the what? Is the 12.5. In fact, that 12.5 is the what? Is it the longest, shortest, or the middle? People, come on.
Longest.
What? It's the shortest, people. Come on. This is the shortest. Which one is the shortest on this side?
JK 5.
5. So I'm going to set up the shortest. The shortest on the left one is 12.5. The shortest on this one is the 5. And I don't think there's any other way that I can do it except cross multiply. I just don't think so. So we'll cross multiply. 5 times x is equal to something that I don't know. So I'm going to go over here, 1, 2, 5, and I'll put the decimal on later, times the 12. So that's 10. And again. All right, so then I multiply by the 2, and then I'm going to multiply by the 1, putting my placeholder, 1 times 521 is 521. Except we really did have a decimal here. Who knows where the decimal goes? In between the two zeros, yeah. It's going to be 150. So right now we've got 5x. 5x is equal to 150. And then what do I have to do to get rid of the 5? Divide by 5. Divide by 5. People, come on. What's 15 divided by 5? 3 with an extra 0. And then I'm going to see if that's reasonable. My shortest side was 5. The middle side was 12. Which is a little bit double than the 5. So this one here is 12.5, and a little bit double than that 12.5 is 30, and that is reasonable. So that is our answer. We've got one. Okay. Going to number 3. This one we probably will do tomorrow. It says, in problem number 3, what is the scale factor from the smaller figure to the larger one? So from the smaller to the larger. So this one, smaller to the larger. What you're going to do, this is a little bit different. We haven't done this before. You're going to take one side, any one side where we've got two numbers. I'm going to take the 12 since this is going to come out. So the smaller side on this side is what?
12.
This is 12. I could have taken any two numbers, but I don't want to work with the decimal. So I'm going to put the smaller side is 12. The corresponding side is what? Is 30. And then let's just reduce this to get a scale. You just find those two numbers and reduce it. So what goes into both of those? Is it 6? So this is going to be 5 to 2. So the scale, it's a 5 to 2 ratio. For every 2 that you have on the small, it's 5 inches on the larger. That's all you need to put. It's 5 over 2. We'll do more of those later, so don't worry about that. And then the very, very last one, and I'm going to help, and this is going to be the only one that you have to finish. I'm going to help you set it up. A palm tree cast a shadow that's 28 feet long. Where would I put that 20 feet? On the height here or on the bottom? On the bottom, because that's your shadow. So put a 28 here. And then a 6-foot sign cast a shadow 8 feet. Where do I put that 6?
On top.
Where do I put the shadow?
On the bottom.
On the bottom. The shadow goes on the bottom here. Where am I going to put that 6?
On top.
On top, because this, right here, because this tells me how high the sign is. It says now, how tall is the palm tree? You're looking for the height. So, do we have enough to do a ratio proportion? So it's right here. So it's what over what is equal to what over what? H over what? So this is the height over the shadow on the palm tree is equal to the what? What's the height of the sign? Is 6 over 8. This is your homework. Finish that up and solve it. Okay? And we'll do more shadow problems tomorrow. You'll probably, if you reduce it, it's going to go imperfectly. I would reduce it first and then do it. And guys, it is about time to pack up. That was all. We did a lot of work. That's the only one.
Goodbye, Miss Shorak.
Goodbye. Have a good day.
Good night.
Good night. Have a good sleep.